So let us look at an example using STL, using a vector, using from the standard library IO stream, which of course we've used. The namespace std indicates that what we're dealing with is indeed a standard library. Again, if namespace was something else, it might be a local corporation library. You might have using namespace AT&T. If the AT&T people wanted to create their own versions. So here we have vector. Vector is a template. That's why it's a standard template library. Remember, template is all about generic programming. So STL is heavily invested in using templates. Indeed, two of the techniques that STL takes advantage of to get some of their efficiency and generality is the use of templates throughout and the use of inlining throughout. STL as a major design criteria is to try and get things that are nearly as efficient as they can be, even if they were hand-coded, and specially hand-coded. Now here's some example code. This is a usual idiom. It's an idiom both for vectors, but also vectors can be treated like arrays. Now, this was used for initialization, and this is more a C-style idiom. Here, you're getting a C++ style idiom. And here you see that you have this notion of iterator, this generalization of pointer. We also sometimes call it a cursor. Understand that it's looking at a position. We have these special functions, Vm, so that Vn is always sort of the sentinel. So end identifies where we are finished with our computation, where we're finished with our sequence. So it's like less than 100. 100 there is the sentinel. That means we can look up through 99. So there is no Vi of 100 where there would not be a V of 100. V of 100. 100 is instead the sentinel. It's one passed. So think of it as one passed, one element passed. And we dereference P, which gets us the contents of whatever that container is, and then we use it in whatever way we want. In this case, it's just for output. So again, here are two of the standard idioms. Both are in use in our coding style, but we want you to move on to this, and we'll hopefully explain why that has value. But STL relies a lot on this second idiom throughout its code. So the iterator logic is fundamental to the use of the standard template library. As I stated, P is conceptually a pointer, has two endpoints that define its range. Begin is actually the starting element and stores a value, but Vn doesn't store a value. Vn is a sentinel that says we're one past where we should be. So we're always testing Vn with a not equal logic. P not equal to Vn is what's very typical.